Hello, this is video 3 for Chapter 9, STA2023 Statistical Methods. In this video, we're going to be talking about comparing two population means. So the idea is when we have two independent samples, two separate groups. So we have some examples we can talk about if it's going to be a paired sample, basically together, we'll be doing a regular t-test, or we'll be doing two independent samples, two separate samples, we'll be doing a two-sample t-test. So number one, if there's a new program to improve memorization of information, we have 20 randomly selected participants take a pre-test on memorization skills, and then after they complete the same participants, after they complete the program, take a post-test on their memorization skills, we look to see if there's a difference. Now keep in mind, we have the same people in both groups, we have a pre and a post. What we're really looking for is the difference. We really just have one group. That would be a t-test. 2, we want to see if using Weight Watchers program versus not using Weight Watchers will help people lose weight. We have 15 randomly selected participants and put them in Weight Watcher group. And we take a different 15 randomly selected participants and put them in not using Weight Watchers to see if there's a difference. In this case, we have two groups, so we'll be doing a two-sample t-test. We want to see if there's a difference in learning based on if the teacher is sitting or standing. We take 10 randomly selected teachers, and each teacher tests the class standing and sitting in the class to see if there's a difference. So we're looking for a difference. It's the same teacher in both classes. That will be a t-test. And the last one, there's a new drug to help with test anxiety. We take 50 randomly selected students and place them into two different testing situations. No students are in both groups. In one testing scenario, the students are given the new drug 15 minutes before the exam. In the other testing situation, the students are given a placebo. We want to see if there's a difference. In the two different testing situations, that will be a two-sample t-test. Okay? So we're going to focus first on a t-test when there's a difference. T-test when there's a difference. So it is believed that taking yoga classes reduces stress. A group of 35 randomly selected participants who suffer from stress were selected to take yoga 2 times a week for 4 weeks. Their initial stress level was measured through a stress survey. The score on the stress exam was out of 50 points. After taking yoga 2 times a week for 4 weeks, their stress was measured again through the same stress survey. The average difference after yoga minus before yoga is reported to be X bar of negative 2.25 with a standard deviation of 1.53. Is there a difference in test scores after yoga minus before yoga at the 5% level? We're assuming the stress level will go down. Now, please keep in mind, we're looking to see if there's a difference. They've already done after minus before yoga, so we have one group, the difference group. They found that the difference is negative 2.25. Now let's make sure we understand what that means. After minus before, when I took after minus before, we got a negative number. Now to produce a negative number, the after must be lower. So for example, scoring a 20 afterwards and initially getting a 30, 20 minus 30 is negative 10. That means your score went down. So negative 2.25 means your score went down. And that's what we're looking for, is if the score went down. Now keep in mind, the difference, the data is negative 2.25. Is that enough to say that yoga works? Now the trick for these is, what is HO going to be? And the belief is there's no difference. No difference, mu equals 0. 0, no difference. So the average difference in stress level for participants in stress, post minus pre after yoga, is 0. No difference. We think it's going to go down, negative, less than 0. The average difference in stress level for participants with stress, post minus pre after yoga, is less than 0. That the stress goes down. Now this is just a t-test. The only thing that's new is mu is 0, being no difference, and then this is going to be mu less than 0. But 0 is what we use for no difference, when there's a difference. Usually these are like pre and post tests. So this is just a t-test. So random sample, check. We have to have more than 25. This first example we do, we have more than 25, we have 35, so we're good as far as normal. And all people with stress, is that greater than 10 times 35, which is 350? There are more people in the world than 350 with stress. Okay? Everything here I'm just going to kind of review because we did this in the last video. But we're going to find our SE, so it's the standard deviation divided by the square root of n. 1.53 divided by the square root of 35, which is 0.2586. Then we do our t just like before, x bar minus mu over your SE, so it's negative 2.25 minus 0 over 0.2586, which gives us the t of negative 8.7. So as we're getting a little bit better at these, negative 8.7 is a really extreme number. It's way, way down here, and we're looking for less than, so your p-value is very, very, very small. Now, using critical values, we're going to compare this negative 8.7 to our critical value, or like our alpha, our t star, which we look at 95% because alpha is 0.05, and our degrees of freedom is 35 minus 1, which is 34. So I'm going to go to the table and tell you how we get that 2.03. Okay, so using the table, we're looking for 95% and 34. So when I go down the table, 95%, and then we don't have a 34. So remember, we look in between. This is 2.042 and 2.021. You can use either one because it's just an estimate anyways. But between them would be 34, so I'm going to go with 2.03. 2.03. Okay, so picture-wise, 2.03 is what we got for t star. It could be positive or negative. Because the other t is negative, we'll make this negative 2.03. So the t is going to give us our p-value. To the left of that, because it's less than, very, very, very small. To the left of the negative 2.03 would be like our alpha, much larger. Our p-value is smaller than our alpha. But if you want the actual numbers, we'll use the calculator. So we go to the calculator. Again, we're still doing a t-test. So we go to stat t-test. In this case, we have the stats. Mu is 0. X bar is negative 2.25. Our standard deviation is 1.53. Our sample size is 35. We're doing less than. We can go to calculator draw. Because the p-value is so small, when we choose draw, we're going to get a p-value of 0. And 0 is okay, it's just never really exactly 0. It's just really, really small. So if we report 0, that's fine because it's so, so small. But our t, we got negative 8.7. Here we get negative 8.7, and again it says 0. If you want the exact p-value, we hit stat, over to test, t-test, but instead of choosing draw, we choose calculate. And it's 1.81, but be careful, it's e to the negative 10. That means we start at the decimal, go 10 places to the left, so it's 0.9018. Very, very, very small. So our p-value is smaller than alpha. We reject HO. There is statistically significant evidence to reject HO. We conclude that the average difference in stress level for participants with stress is less than 0. So basically, yoga works, it's less than 0. But less than 0, is it a little bit less than 0? Is it a lot less than 0? What is it? So if I'm going to spend the time on it, how much lower will my stress go? That's answered by the confidence interval. So again, it's random, it's normal, and our confidence interval is x bar, negative 2.25, plus or minus t star, 2.03, times our SE, 0.2586, negative 2.25 plus or minus 0.53, gives us negative 2.78 and negative 1.73. Notice both those numbers are lower than 0, which is what we said, and the negatives means lower, lower. So when I interpret it, I'm not going to put negative, I'm going to write lower. So we are 95% confident the average difference in stress level for participants with stress, post minus pre after yoga, is between 1.73 to 2.78 lower.